In example 2, my instruction is to prove that the left-hand side is the same as the right-hand side. As all of the angles are x, I'm going to start with the left-hand side because that looks more complicated. So starting with the left-hand side, as it is made up of two terms and the right-hand side is made up of only one term, I'm first going to find my LCD. Sec x minus 1 is a bracket factor, and sec x plus 1 is another bracket factor. Finding my common denominator, which is going to be both of these bracket factors, in other words, sec x minus 1 and sec x plus 1, my new numerators, first of all for the first term, is going to be the old numerator times by the factor that it did not have, which is sec x plus 1. And the second adjusted numerator is going to be the old numerator of tan x times by the factor in the denominator, which is now in the LCD that it didn't have, which is going to be sec x minus 1. In my next step, I'm going to multiply out the terms in the numerator and the brackets in the denominator. So the numerator is now going to be tan x times by sec x plus tan x, and then minus tan x sec x plus tan of x. And if I multiply out my difference of two squares factors in the denominator, then I end up with sec squared x minus 1. You can see that by adding like terms in the numerator, my tan x sec x and my minus tan x sec x add up to 0. And so in other words, in my numerator, I am just left with 2 tan x. Let's take a look at that expression in the denominator. Do you remember that one of our square identities said that if I have 1 and I add tan squared x, that is in fact the same as writing sec squared x. If I now take the 1 across to the right-hand side, I could have written tan squared x is the same as sec squared x minus 1. So in other words, instead of writing sec squared x over here in this denominator, I'm in fact going to write it as tan squared x. And as I have only factors in my numerator and my denominator, I'm able to cancel 1 tan x ratio in the numerator with 1 tan x ratio in my denominator. In other words, I'm left with 2 all over tan of x. If you take a look, this is still not what I wanted in my answer, but 1 over tan of x can be written as its reciprocal, and the reciprocal of tan of x is cot of x. And so instead of writing it as 2 over tan x, that's the same as 2 times by cot of x. This is what I wanted, and so I have arrived at the right-hand side and proven the identity.